For question 3, without using calculator, we need to evaluate the following by using the factor formula. This means that you need to either use product to sum identities or sum to product identities. For part A, we have subtraction. So this means that this is a sum, and hence we need to change it to become product. So we'll be using sum to product identities for part A. Let 105 degree to become A and 15 degree to become B. That will give you sin A minus sin B. And this is the formula that we need to use since we need sin A minus sin B. So now we just need to substitute the value of A and B into our formula here. A is 105 degree and B is 15 degree. By simplifying, we will get 2 cos 60 degree and sin 45 degree. So for cos 60 and sin 45 degree, these are special angles. Cos 60 is 1 over 2, sin 45 is square root 2 over 2. And we can cancel out 2 with half. And the final answer is square root 2 over 2. Part B is 4 cos 15 degree times sin 75 degree. So this is a product multiplication. And since the question asks us to use the factor formula, therefore we need to use the product to sum identities. We have cos times sin, which is here, and the coefficient should be 2. Only then we can use this formula. But since our coefficient in our question is 4, we can change 4 to become 2 times 2. Let 15 degree to become A and 75 degree to become B. The coefficient 2 outside the bracket remains the same. But for 2 cos A sin B, we will apply the product to sum identities, and that will give us this formula. So now substitute A and B back into our formula. A is 15 degree and B is 75 degree. But be careful, now we have negative angle. Sin negative alpha is equal to negative sin alpha. Therefore, sin negative 60 degree is negative sin 60 degree. And the final answer is 2 plus square root 3. For question 4, we need to prove that this identity is true. We can see that the left-hand side is more complicated, so we will start with the left-hand side first. Since our final answer is tan, this means that we're supposed to get sin over cos. So we need to have sin from the numerator and cos from the denominator. Note that here we can apply sum to product, and the same goes for the denominator as well. We can also use sum to product identities. So let's look at the numerator first. Since we have cos minus cos, this is the sum to product identities that we need to use. Therefore, by comparison, A is 2B. So A here will become 2B and B is 2A. So B will become 2A. For the denominator, we have sine plus sine. And this is the sum to product identities that we need to use. Therefore, by comparison, A is 2A, so we're going to change A to become 2A, and B is 2B, so we're going to change B to become 2B. By simplifying, we can see that this will give us B plus A. This one is B minus A. This is A plus B. And this is A minus B. And we can cancel out 2 with 2. Sin B plus A with sin A plus B. So we'll be left with negative sin B minus A divided by cos A minus B. Now, let's compare with the final answer that we should get, which is tan A minus B. We can see that the final answer should only have A minus B. But in the numerator, we have B minus A, which is not what we want. So we need to change this to become A minus B. Let's recall the negative angle, where sine negative alpha is negative sine alpha. Here we have negative, so this means that this can be changed to become the negative angle. Therefore, negative sine B minus A is actually sine negative B plus A, which is just sine A minus B. So this is actually sine A minus B. Since the angle is the same, which is A minus B, therefore sine divided by cos will give you tan. And hence we will get tan A minus B, which is our right hand side, and that is how you show that this identity is true. So let's recall, if sine x divided by x, that will give you x. This is correct because the angle is the same. That's why we can change it to become tan. But if you have sine x divided by cos 2x, here the angles are not the same, therefore you cannot change it to become tan. This is wrong because the angles are not the same. So that is how you prove for this question.